All right, picking up where we left off, we finished with a very important statement yesterday about normal conditions and checking that it follows the conditions. Next, we are moving on to the empirical rule. So this is the 68, 95, 99.7 rule. Almost looks like a social security number. So in a standard normal model, %68 of the data falls within plus or minus 1 standard deviation of the mean. 95% is within plus or minus 2 standard deviations. And 99.7% is within plus or minus 3 standard deviations. Like a capital S, capital D. Everybody good? Alright, so drawing a normal curve is next. It's like maybe 1/3 of a page, so it depends on how much room you have. It also depends on how big you draw your picture. Alright, drawing a normal curve. I'm drawing mine kind of big just so y'all can see it. Yours don't have to be this big. Yeah, there's stuff to go inside and stuff, well, a little bit to go on the outside. Alright, so this first one, okay, over here. Try to use this color and see if we can see it. You have labels on it, okay, and the labels are going to be based on like your specific problem, okay, but just the generalized form of it we're going to do here, and then we'll do an example of a more like specific one over here. So dead center is 0, 1, 2, 3. So in this this -1 to 1 area, it is the 68% Yeah. Trying to make it a little darker. And then from -2 to 2, that is 95%. And then from -3 to 3, that's 99.7%. Alright, so then based on a specific model, what does this 30 and this 5 represent? Huh? What does the 30 and the 5 represent? So what is 30? Huh? Yep, mean and standard deviation. So this time, rather than 0 being dead center, we have 30 being dead center. We're going away in increments of 5. No. Yeah. So it's only negative if you're like not. Yeah. Well, you wouldn't be doing it, like, you wouldn't have a gap that big, because your standard deviation is that number there. If your increments are based off that. So unless you have like 30 and then you have a standard deviation of like 15, you're not going to actually hit the negatives. So from 25 to 35, you have your 68%. From 20 to 40, you have 95%. From 15 to 45, you're 99.7%. By the empirical rule. And this was just a problem dealing with fuel efficiency in miles per gallon. So then as a result, we can write statements such as approximately 95% of all cars will have gas mileage between 20 and 40 miles per gallon. Huh? Or just saying cars, I don't know, it could be. Oh, probably not. There's a lot of cars now that can get like 60 miles to the gallon, so probably isn't real accurate. Unless they're just purely looking at one of each different type of car. If this was of all cars in the United States, then that would be one thing. If we're just looking at like one of each type of car, like one Corolla, one Camry, one 4Runner. No, it would still be miles per gallon because they do still run on some gas. It's just not nearly as much. They just have like maybe 5 gallons of gas in them. I don't even know if it's that much, like 2 or 3 gallons of gas in them, I think, to get them basically to a charging station if something happened. Well, you can also bring stuff with you to like a mini charging station almost, I think, like that you can keep in your car. But I don't really know how that works, so. Do I in my car? Like 18 or 19. Around town. On the interstate, like 23. You don't have to just like stop and go and all that, so. Finding normal percentiles. We still have like a page and a half if we do them all. We'll see. Yeah. I mean, I assume if we stop a little early, you'll have something you would study. We will see. When a z-score isn't exactly 1, 2, or 3 standard deviations, we have to use the z-table. And I have to verify this is right, but it should be A74 in your book. Or a calculator. The z-table tells you the percentile value for any z-score. Alright, so an example. The normal model for SAT math tests, or for a SAT math test is 500 with a standard deviation of 100. Normal. What percent of students score below 450? So just always a good idea is to draw what you're looking at. Okay, so we know that the mean is 500. We know that standard deviations are 100. Okay, and so on and so forth. Okay, but we want to know what this area over here is with less than 450. So we would use our formula for a z-score, which is what? So the y is going to be 450. minus y bar is 500 over the standard deviation is 100. So this comes out to be minus 0.5, and we don't know exactly what that is. Okay, so I'm going to see if the z-table is right, and we'll look at that really quick as everything falls. Huh? Okay, A74 is not correct. I need to check and see. All right. All right, it's on A102, not A74. I need to see if I can get this to actually focus in on the book, or it's going to be really hard to see. All right. Huh? It's on 102? Yes, I am. All right. Yes. So, okay, at the top you have it's the second decimal place in Z. Okay, over here is the Z value. So in our case we had minus 0.5. Okay, so we come down to minus 0.5. Okay, let me see if I can zoom it out and still be able to see everything. Okay, so you come down to the minus 0.5, that's what we had. We didn't have another decimal place after that, so we're looking at this one that's 0, 0. So we come all the way down, so 0.3085 is the answer. So it's the Z is minus 0.5, that was the value we just got, and then it is, the second decimal was a 0 because we didn't have a second decimal. So we come down where they intersect, it's that number. Okay, this one is for the negative values, okay, or on the left-hand side here. Over here are the positive values, and it works the same way. So, huh? No, you have to memorize the whole table. Okay, so it's 0.3085, okay, from the table. Okay, which that means that approximately 30.85% of test takers score less than 450 on the test. Okay, and this problem is going to be continued, but I'm going to have to go to another page to do it, because I don't have enough room at the bottom without like completely squeezing it in. Everybody good with this page? Alright, so now what we want to know is we would like to find out, what was I just writing it? So now we want to know what percent of students score between 450 and 600 on the test. So we already know what Z of 450 was. Okay, that's what we just found, which was the 450 minus 500 over 100, which was minus 0.5, which gave us the value 0.3085. Yes. So now we need to do Z of 600. 600 minus 500 over 100. That's just 1. Okay, so looking back at the table, A102. This one's A103, but yeah. And also we do still need to draw our picture for this one. It's in the back, like behind the answers. It's like the last 2 pages of your book. Is it A74 in your book? Well, maybe it is A74. Mine is A102. Maybe mine just has extra stuff in the back that I didn't realize. Okay, well, I'm going to go fix that real quick. What do you think it is? Yep. Okay, so where did you go to do that? How'd you get that, Alyssa? Okay. Yep, so there's no decimals after that, so it's just the 0.8413. Nope. We want to know what percent of students score between 450 and 600. So we're actually looking at, okay, you have 500 here, 600 here, 450 there. So I want to know this area in here. Yes, so I need to subtract, okay, because that's why it's important to draw the picture so you know what you're looking at. Okay, so 0.8413 minus 0.3085 gives you what? You're close. 0.5328. Okay, so this means then that approximately 53.28% of students score between 450 and 600 on the test. I'll give you the Z tables. Just 2. If you need more than that, something's wrong. Alright, we have 1 page left of stuff. We can do one more thing in notes and one small example and stop, or we can just go ahead and finish them. We have 20 minutes left, 22 minutes left. Okay. Huh? Alright, percentiles to scores. Alright. So we can also use the Z table to determine cut scores for specified percentiles. We find the corresponding percentile. It sounds confusing, but I promise it's actually not actually that bad. We find the corresponding percentile in the Z table. Translate it into a Z-score. Then you can use the Z formula to find the cut score. Okay, Z formula meaning Z is equal to Y minus the average over standard deviation. So example, what score marks the top 10% of the SAT test scores? Alright, so now we're going to basically be using the tables in the opposite direction, which means I need my book back. Okay, so we're looking at basically this Z here, which is 10%. So the top 10% is the 90th or the 90th percentile. On the Z chart, and then we're going to look at the value there and how we find that. Give everybody a second to write that down before we go look at the table. Alright, so now we look at the z-table, but we're looking at it in the opposite direction. We're looking for the 90th percentile, meaning I'm looking for a number that's like 0.90 and then something really, really small after that. Okay? So, looking at my table, bring it down a little bit. I'm looking for a number that over here is like 0.90-ish. Okay? So, yep, that would be the smallest one. There's nothing else that's 0.90 and anything smaller. So we'd be looking at this one. Okay, so we would say, what the next thing you can write where I said, on the z-chart, you would write 0.9015. .9015. Okay, and then we want to know what is that actually in z-value then. So I follow it, I go up, and I go over. So it's 1.29. Okay, so this is 1.29, in case you're just using the table in the opposite direction. So now I'm using this formula, but I know my z. I want to know this y value. So I set it up. 1.29 is equal to y minus, my mean is still 500. My standard deviation is still 100, okay, from the previous thing. So then I just need to solve for y. So I get 129 is equal to y minus 500. So then I get 629 is equal to y. And then interpreting what this means, basically scores in the top 10% are 629 or higher. And that's all for that. So that's a good place to stop. The rest of it is stuff that just talks about if you're using your calculator, little reminders and stuff like that.